Hello and welcome to the second part of this tutorial on Plotly and Dash. In this video, what we'll do is implement this data table in which it's showing like this very large pandas data frame coming from a CSV file. As you can see, there are like many countries. It's paginated, so I can go down and up. It's not exactly good on the layout side of things, but this will be covered on the future. And it also has many columns. As you can see, there are like columns to the right. So I implemented also custom buttons, which also does the pagination to the left and right, as you can see here. So let's go to the code. So here in the code, as you can see, it's fairly small, but since this is a tutorial, we'll also go through everything step by step. Not just looking, but I'll also implement with you. But just as notions, there is pandas, which I'll be reading from a CSV file. There is the bootstrap component that we made at the quick start in the last video. There's also the dash data table, which we also did in the past. And we'll also see how callbacks work, which is basically how to make UI elements update depending on UI interactions. So in my case here, I guarantee that if my next page or previous page buttons are clicked, I actually update things in my page. So first of all, what is this life expectancy? What is the data that I'm actually going to use in this tutorial? In case you never saw this before, there is a website called Gapminder.org in which you can gather a lot of data, and Gapminder is a visual analytics tool, or more visualization tool than analytics, in which you can see trends of data of different countries in the world by time. It does animations. It can allow you to understand why, not exactly why, but what happened in the past over many different data sets. As you can see here, there are like ginormous amounts of data sets that the Gapminder team has actually provided. And this was recently bought by Google, I think. So it's definitely a good thing to check out. So in this Gapminder, we can also download the data. So if I go to, not data, if I go to gapminder.org /data, I can download the data itself to myself. So I'll download the life expectancy data, which to me is one of the most interesting data that they have. You can like preview the data table over here after it finishes loading. And you can also download the CSV. So just click this button to download the CSV, or also check the GitHub repository in the link in the description below. So going back to my project, I will just create a new file. I'll call this, let's test for now. So in my test, what I first want to do is to use pandas to read from the CSV. If I open the CSV, I can see there's a lot of data. In my test, I'll import pandas, SPD, and I can use pd.read CSV to read from a CSV file. So I will get the life expectancy and I'll just print it out. So if this is life expectancy, or DF. Usually people use DF, so let's use DF. So if I just stop everything running and run this test, I'll see the entire data table over here. As you can see, the data table has like almost 200 rows, almost 300 columns. The columns are by the year, the rows are by the country. Of course, if you know pandas, you know that we can like shift and match, do different kinds of things to change this around. For now, let's just leave it as it is and make sure that I can visualize the data. There are two ways of visualizing a large data like this, using scroll, which is how Gapminder team did here. And we could also do the same thing using data table and dash. But to change things up, let's do the pagination way, in which you guys saw in the beginning of the video. So for this, I'll just leave this test here. I'll just change this name to backup and create a new app. So I'll just get from my quick start the table. So this is the table that we saw before, and I'll change this to my own life expectancy. So with just this, I will be able to see the entire life expectancy data table all at once, which will be fairly big. So it'll take a while. And depending on your computer, you'll notice that it's probably never actually going to load. It takes a while, but it, as you see now, actually loaded. It's like this ginormous thing, and you can barely use it because there's too much data, there's no interaction, so it's kind of useless for now. So what we'll do is to first reduce the number of rows. This part will be fairly easy because dash data table has a parameter called pagination. So there are page size, page current. You can make use of this feature to be able to use pagination in your data table. I'll just set the page size to 10 or to 30 maybe. I saved it. I'll just refresh everything. If I come back here, now instead of showing all the rows, it will only show me the first 30 rows and will give me this nice little buttons on the right bottom corner. So I can go and run through the rows, but as you can see, it's still very slow because there's so many columns. Each column has like 300 entries. It's not very user-friendly, let's say. So the next thing we'll do is also paginate the columns. So the columns, instead of doing like this, though I don't think there's a default way of paginating columns, not very usual, but just so you understand a little bit more of what is a data table, you can see there's the ID, which is just used for identification throughout the web service, columns, which is the columns that we are showing, the data itself, and what is the page size that we just included. So in case I want to make only a few of the columns be shown, I can do something like this, and now only the first 10 columns will be shown. As you can see here, it's extremely faster. I can go through the rows with no problems, but now I can't actually see everything. So let's implement the buttons. So first of all, how do I include now the buttons over here? You can see that my layout equals one single thing. So from my bootstrap, let's copy this first part. So as you can see, the first part will add to this thing. I'll just remove it. I also have to include what this DBC is, which is this thing. So now I know what DBC is. And also from my layout, you can see there's something else, an alert. What I'll do is I'll use something from Bootstrap called container. So instead of having the data table being the layout, I'll get dbc.container. And in my container, I can have an array of things. The first entry can be the data table itself. And I'll just make sure I'm closing the things in the proper place. This one I need to close here, this one over there. And now I'll be able to include multiple things inside my container. Notice that if you don't want to use Bootstrap, you can also include dash HTML components like this. And instead of using a container, you can use just a plain old div, which is like also a container, but not Bootstrap container. And a container allows us to have multiple things. So again, we don't actually see anything added over here, but if I actually add, say, a text, I need to rerun this because there was a bug. And when there's a bug, my debug over here stops working and crashes the server. So I need to rerun it. And now, as you can see, because of my container, the table is now centered. I can also make it not centered if I say I want a fluid container, and say over here, fluid equals true. So with this, my data table will fill the screen in case this is what you want. So I just remove this because it will be easier to see all the columns in a better way. And as you can see, there's also two things in my containers. Instead of having now the text, I want a button. So how do I do a button? Back in the Bootstrap page where we got the quick start, you can also check the components over here. One of the components is the container that we just saw, which is in layout. As you can see, there's a lot of information about how to use rows, columns, and some other things. And what we want now is a button, which is used like this. So let's just copy two of the buttons to see how it will look like back in our web service. Now we have actually two buttons. Let's use just a secondary style of the button. So use like this. I'll want one called previous and another button called next. And now our buttons are ready to be attached to a callback function. So what is a callback function in the dashed context? We can define app callback functions like this, which basically calls a function that we specify. In my case, I'll just say paginate, something like this, and I'll print out something just for now, in which I'm able to specify over here inside this parentheses what are the IDs that I want to watch for updates. In my case, I want to watch for updates in these two. So I'll add ID, say button previous, ID button next. Good enough. So back here, if I click Control P, you'll notice that what I need to pass into this callback annotation is the outputs, the inputs, and some other information that we'll not use for now. The output is what I intend to update in this callback function, and the inputs is what was pressed or what was selected, and from where I want to trigger this callback function. So first of all, my output, as you can see, I can Alt Enter to import this name into dash dependencies output. So there's also the input over here, which we'll do like this. So first of all, the output, I want at least one output, which will be the columns of my data table. So I have the ID. I need to pass inside the output the component ID and the component property. The component ID will be the table, which is the same, the ID, which is over here. And the property is what is the property inside the table that I want to update. In my case, will be columns. Once I do this, I actually shouldn't pass what is a column directly in the layout, and only allow the callback function to update it. This is like how Dash is structured to be worked with. So from here, I can say I want two inputs. So there will be an array of input. The first input is the bprev. And in a button, the component inside or parameter inside a button that I want to check is called nClicks. So the number of clicks that this button was done. And I also want another input, which is the button next. Same way. These inputs will be passed into my callback like this. So if I just print them out, you'll see as I click the button, this number will increase over time. And I also need to return the output that I'm expecting, which is this columns over here. I'll just copy paste this over here, save, run it again. It's running. Let's just refresh here to make sure. I'll click next several times. And back here you can see that my print is printing at first none, and then 1, 2, 3, 4, 5, 6, 7, 8. So the n clicks is a number of times the button was clicked. If you need to check how many times the button was clicked, this is wonderful. If you want just to check if the button was clicked or not, then there's a separate function that I found in the internet. I'll just copy from my previous code, which is this one. So with this, I can extract information from the callback context of this callback. So I'll have the ID of what was changed to this callback to be called. So if I just print this out, just waited for update, okay. As you can see, at first, none, and this changed ID is just dot. If I click next, the bnext is 1, and the changed ID is bnext.nClick. So it's exactly what was changed in that input that made this callback to be called. So with this, I'm able to do several things. One possible solution, I'll give two, for this pagination schema here is say, if I want to paginate, I can say my page at first is 0. If my bpress next is not none, I'll just add it to my page. And oops, and same thing to my bpref, but I'll subtract it. So with this, I'm able to say I want a 10 column by page table. I can just say I want from page until page times 10 until page plus 1 times 10. So the next page, I'm able to show 10 entries in my column, in my data table, 10 rows in my data table at once. So if I click next, you can see I go to the next and can come back. And it's very synchronized, if you see. So country is going until 1808. If I click next, now I'm going from 09 until 18 and so on. Of course, I can change this a little bit so that I can, like, for example, always have the first one, or I don't know, something else. Oh, this is another example. This wasn't in our example in the beginning of the video, but let's do this now. I want the country to always be shown, and if I click next, only the numbers over here will change. So in this case, I always want the columns 0, which will be something like this. So I always want the 0, and my page will paginate from 1 until whatever I'm doing here. So something like this. So I just add these two arrays, and with this, my country is always the same, and I only change the numbers because I'm making sure that always my columns 0, which is the country, is in my return or in the columns part of my data table, and I only change whatever is next over here. The second solution that I'm going to say is just using this, just to exemplify. So say I have my page is 0, it's already here. What I'll do is a little bit more complicated, but it will be a nice platform for you to be able to use different styles of solution in your specific web application. What I can also have in my container is an empty div. So going back here, I can include the HTML components like HTML, and I'll add another entry in my container as a div with just nothing inside, but with an ID called, say, page. And I want it to be hidden. So I say hidden equals true. So if I do this, now I have a hidden component, hidden div, which is page. And now I can, instead of doing like this, I can change my page, updating what's inside this div, and then have another callback saying if this div information is changed, then I update my column. So I'll just copy paste this over here. My first callback will be to update the page. And the second one is to actually paginate the table. So if I want to update this page here, my output will actually be this page, and the parameter will be children, which is the children of my div. And instead of just outputting everything, I'll just output the page itself. So this way I can say what is the specific page that I want. And I can also request what was my previous page, doing like this. I don't know if you remember, but inside my callback, there's also this state. The state is basically an input like this, these two, but if you don't want to call this update, if that specific input is changed, only if these two are changed, then you use state, which means I only call this callback if I click the buttons, but not if I change the page itself. So I'll add over here the state. Grabbing state over here, I add state, and my state will be the page children. Same thing as the output. If you try to put the output in the input as well, you'll notice that dash throws an exception. And state also needs to be an array, like this. Okay, so now I'm able to get the page. Instead of saying my page is 0, then my page will be this page unless it's none. So if page is none, then page equals 0. Otherwise, just don't touch page. Use the page that is already stored inside. And finally here, instead of adding and subtracting like this, like comparing how many clicks there were, I will check if the button was pressed or not. So to do this, I'll do something simple. I'll just check if this string is inside this changed ID or inside over here, which is the next one. If previous, I want to subtract one, so just say like this, and if next I want to add one. And finally, I update my page itself. Notice I'm not using anymore these two values, but I need to be explicit on their existence because of my input. If not, there will also be some problems. So just leave these two over here. And now for my next callback, what I want to do is to watch out for the page change. So just grab this output, but I'll change it into an input. So if my page change, I will get my page, and if it's not null, which is always required to be checked, if it's not null, I just update it with 0 and finally do this. So if I save, I'll just run it again. Oh, this is the opposite, right? So if it is none, replace it with 0. And over here, I noticed that it's not is that I want, is in. So if this text is inside this text, so little bug fix. So if I run this, now the same exact functionality that I had before, I have over here now. Notice that in this way, I'm able to check if my button was pressed, whether it was pressed or not, instead of checking how many times it was pressed. Sometimes I won't be able to use the how many times it was checked, it was pressed for my own application. So just have in mind these two separate styles of checking if the button was pressed or not. And also this little nifty functionality of storing data inside the browser by just putting it inside a hidden div. So with this, we conclude our tutorial. We managed to make the data table that we showed in the beginning of the video. And next video will include visualizations. So probably bar chart and line chart, and make sure that they both also sync with whatever is being shown, clicked, or filtered within my data table. See you next time.